Hello guys and welcome to our channel. I'm Utsav Gada. Today I'll be teaching a hands-on end-to-end project right from the scratch till the deployment. I would highly encourage you all to work simultaneously. In this video, we will start with understanding the dataset and cleaning, model building, followed by Flask using Spider. We will work on HTML, CSS and create our Python application, and finally deploy it using Heroku. So let's get started. So very first step to create a project is to create an environment. Now, why is the environment necessary? The environment creation is necessary because if you're not creating an environment, you will have all the libraries which are pre-installed run within your model, and that will just slow down your model as you don't need all the libraries which are being pre-installed. So unused libraries will basically make your model slower, and that is why we need an environment. How to create an environment? First thing is just go to your Anaconda prompt. Just type conda create -n your environment name. For example, I write incomepred, and then finally the Python version you want to work in. So I want to work in Python 3.7, so I'll write that. It says already exists just because my environment has already been created. After this step, you just have to write activate and your environment name, which is incomepred. Once this is done, just go to the folder, just give the path of your folder. Now you are in the folder, just write Jupyter Notebook to open your Jupyter Notebook. My whole code is in Jupyter Notebook, so I'll open my Jupyter Notebook now. And there you go. After opening the Jupyter Notebook, you have to open a Python 3 file and write your code here. Just to save time, I've already written the code and I'll explain you it step by step. I will be sharing this Jupyter Notebook along with the whole folder. I'll upload it on GitHub, and I'll just give the GitHub link in the description below. Yeah. Starting with the libraries, there won't be any libraries installed as it is a new environment, and thus you have to install the libraries. Just copy paste this code and uncomment it, or else if you are typing it on your own, just write pip install and your library name. It is that simple. Once the libraries are installed, just go to your import those libraries. Once the libraries are imported, Now I'll just show you the dataset first. So here in the folder we have two different types of CSV files. One is the train and one is the test. The train CSV is where your whole training will be done, and the test CSV, you'll just work on, you'll just test your data set with the CSV file. So here, what I'll do is I'll just teach you on the train data set, and I'll expect that you work on the test data set yourself. Now, I'll just show you the data set first. So we have around 12 to 13 independent columns here, naming age, work class, age, the person's age, work class, what is the education, and many more, such as marital status, occupation, relationship, race, sex, capital gain, capital loss, hours per week, native country. And based on these independent factors, your dependent factor will be shown. So this is our data set. Let's get back to the Jupyter notebook. Here, first, let's start with importing the data. I'll write a variable called data frame, which is abbreviated as df. I'll just write pandas.read CSV and give my CSV file. If you are new to Jupyter Notebook, I'll just suggest you to first upload your CSV file from here, and then just give your name, and the CSV file will be uploaded. I'll write df.head, that is data from frame.head. What it will do is it will just show you the first 5 values of the data frame. So you'll come to know all the columns here and what is the dependent factor. Coming next, so we'll find just the unique values here. We have run a for loop for I in dataframes.column. Just print the name of the data frame, colon, and all the unique values which are present in that column. Here we can see that age has many unique values on your data set. Work class are limited. I guess there are 7 to 8 work classes, naming state government, self-employed, private, federal government, and many more. The education, if the person has done bachelor's, 11th, master's, 9th, some college, professor, school, anything. So we can see all the unique values here. I'll just write dataframe.info to get more info about the data frame or the data set. Here we can see that age has 32,561 columns in total. Work class has 30,725 columns in total, and so on. It also shows if the column is an integer value or an object value. For example, the age column has integer values only. The work class is an object value. Next, let's get into the cleaning part. So there are various ways to clean your data set. First, let's check the null values. So we can see that the work class, occupation, and native country columns have a few null values. But as compared to our data set, in total we have around 32,561 entries, and as compared to that, the null values are very less. So the simplest way to clean the data set in this case is to just drop which have null values. So let's do that. Now, again, using the same code, we can just see that there are no null values left because all the null values have been dropped and there are 0 null values present now. Next, we'll remove a column. So as we saw in the data set, there's one column which is not much of a use while making a decision. So we can just remove that column. So just type df.drop and write the column name. Here we have written in place equals to true. This is necessary so to make the changes permanent. So once we write in place equals to true, it will be permanently deleted from the dataset. So doing that, Now we'll try df.head50 just to show you the 50 columns. So basically, if you don't write any number here, it will by default show you 5 columns, but if you write any numbers, it will show you that many columns. For example, here it is showing us 50 columns. So we can just check the data set as we want, and also because of the previous command, now we can see that the column has been removed. Moving forward, let's explore the dataset a little bit. First, we'll be starting with the numerical values. Let's explore the age variable first. So here we have written data frame, the column name, which is age dot describe. So it will just describe, it will just show you all the count, mean, standard deviation, minimum value, maximum value, 25th percentile, 50th percentile, and 75th percentile. So here we can see that the count is 30,162. That is, we have 30,162 rows here. The mean of the age is 38. The minimum value is 17, and the maximum value in the dataset is 90. Moving forward, let's plot a box plot of the age column. So here I have used Plotly to plot the box plot. So basically, the reason for using Plotly is it is more interactive, and if you hover here, you will get all the values present. Also, you can crop the graph as you want, and you can view a better picture. I'll just zoom out. Yeah. So I have written here data frame, the Y column, which is age, and the color is income level. So basically, we'll have two different box plots, one with the income level less than equal to 50,000, and the one with greater than 50,000. And I have just given a title and a label here. So let's explore this a little bit. So we can see that we are having the minimum value, which is 17 here, and the maximum value 19. The upper fence is at 73. So basically, all the values after 73, all the dots which we can see are the outliers. Similarly, for the income level greater than 50, we have our first quartile at 26, the third quartile is at 45. Moving forward, let's see the education number, the number of years of education. Here, the same, we have 30,000 rows, 30,162 rows. The mean number of years of education is 10 years. The minimum education is 1 year, and the maximum education is 16 years. So the 1 year is basically an outlier. Let's check in the box plot. So yeah, we can find a lot of outliers here. These dots are all outliers, and similarly we have the lower fence is 8, upper fence at 11, the maximum value 16, minimum value 1, the third quartile at 10. Similarly, checking the capital gain, here we can see that there are many values which are 0. So basically, it is not able to give the 25th percentile, 50th percentile, and 75th percentile. The mean is 1092, the standard deviation is 7406. Similarly, for the capital loss. Next, hours per week. So we can just check that the minimum hours people have worked is 1, and the maximum is 99. So this is again a typical example of outlier, because it is not possible to work 99 hours per week. The 25th percentile is 40, 50th is 40, and 75th is 45. So there will be many outliers, I'm supposing. Yeah. So that's all about the numerical variables. Let's get into the categorical variables now. For the categorical variables, we will be using Seaborn, that is abbreviated as SNS. We'll be using a facet grid, and we'll be creating the graph. We'll be plotting the graph based on the income level. So we'll be plotting two graphs one with less than equal to 50,000 and the another one with income level greater than 50,000. We will be using a histogram here. Let's start with the work class variable. Yeah, so here we can see that in the private sector, more than 15,000 people in the private sector have the income level less than equal to 50,000, and around 5,000 people in the private sector have the income level greater than 50,000. Similarly, in the federal government, a very few, basically I think around 300 or 400 entries of 300 or 400 people will be having the income less than equal to 50,000, and around 200 people will be having the income greater than 50,000. Let's move forward. Next graph is with respect to the occupation. Yeah. So here we can see that most of the people in ADM clerical, in armed force, in other services have the chances are more that their income level will be less than equal to 50,000, and probably, and the sectors such as executive, managerial, private house services, sales may have more people with the income level greater than 50,000. Moving forward, in the marital sector, the people who are married are more likely to have their income, the family income level greater than 50,000 as compared to the people who are separated or widowed or say never married. Next variable is the relationship variable. Here we can see that the income level is less than 50,000 for the people who for the relationship not in family, own child, unmarried. Next, the sex column. Here we can see that the males have the salary less than equal. More males have the salary less than equal to 50,000. Even more females have the salary less than equal to 50,000 as compared to the income greater than 50,000. Here we can see that most of the entries are of white people, and around 20,000 white people have the income less than equal to 50,000, and around 7,000 people have the income level greater than 50,000. Similarly, the data set states that the black people, around 3,000 or 4,000 black people have the salary less than equal to 50,000, and a very few of them have the salary greater than 50,000. Before building the model, it is very necessary to handle the categorical values. So what we will do is we'll create a data frame known as cat columns, and we will put all the categorical variables here. Then we will run a simple for loop and check the unique values. So what we are doing is we are running a function called length, and for in the data frame cat call, in the particular feature, the particular column, we'll take the unique values and we'll take a length of it. So we'll take a count of it. So here we can see that work class has 7 unique values, education has 16, marital status has 7, and so on. Once this is done, now we'll first, as you can see here, our data frame has these values less than equal to 50 or greater than 50k. So first we have to handle these values. So what we'll simply do is we'll just replace 50k with 0 and greater than 50k with 1. So this is that simple. Once the code is run, here we can see that the values have been changed to 0 and 1. Now for the other variables, there are n number of ways to handle these categorical variables. In our case, what we will do is we have limited values. We have limited number of labels, so unique values. So what we will do is we will take the work class variable. We will first take the data frame and we will use the group by function. We will group the work class with the income level, and we will take a mean and we will sort those values. So once I'll just run the code. So once the values are here, we can see the sorted values. Now we will run one for loop and we will change all these values with the numbers starting from 0. So we will enumerate the work class labels starting from 0. So once this is done, here we can see that all the categorical values have been replaced with numbers. Similarly, we will do it for each and every column. And as we can see here, what we are doing is we are mapping the data frame dot native country, the original data frame, and we are replacing that original data frame with our new values. We are replacing the original data frame columns with the new values. Now I'll just do df.head, and here we can see that all the values have been replaced with numbers. There are no categorical values left, and thus now we can build the model. For building the model, here we will use scikit-learn library, and we will first do a train test split. So basically, I had told you in the beginning that there is one different train set and there is one different test set, and that is for you. But what I will do is I'll just work on the train set, and the test set will be what I expect you to do. So here, as we have a lot of values, we have around 31,000 entries. I'll split the data set and I'll create a test and a train section, and I will work in the single data set only. I'll just import it first. Then what I will be doing is the X column is our independent column, and thus I will be selecting all the columns in the data frame except the last one, as last one is our dependent column. Similarly here, Y is our dependent column, so I will just be selecting all the values within the last column. I will be creating 4 different variables known as xtrain, xtest, ytrain and ytest. I have kept the test size as 0.30. So basically my 30% will be the test data set, and the training will be done on the another 70%. I am using decision tree model here, decision tree classifier. I'll first import the decision tree classifier. I'll create the model here, and I'll fit my xtrain and ytrain. Once this is done, I will be printing the accuracy of the tree classifier on the training set and also on the test set. So I have used the function score here to print the accuracy. Now let's predict our model on the X test. So what I'm doing is I'll create a prediction and I'll actually do the prediction on the X test now. The prediction is done. Now I'll be creating a confusion matrix to test whether our model has worked as expected or not. So here we can see that the true positive and true negative values are of good numbers. So we have got 5,971 true positive values and 1,412 true negative values. So basically this plus this values have been correctly predicted. Moving forward, we will generate a classification report. Here we can see accuracy, precision, recall, F1 score, support, everything. And finally the accuracy. So we got an accuracy of 81% here. The same thing which is done in the training dataset is also done in the test dataset. I'll be sharing this Jupyter notebook and you can just refer it, and I expect you to do the test dataset yourself, the cleaning process basically of the test dataset yourself. Once the model is done, once the model is created, for end-to-end project we have to create a pickle file. So just uncomment this code. So I'll just import pickle here, then I'll be creating a variable called as file and I'll open. So basically we have to write the pickle file name which we want to give, and we have to give write permission. Once this is done, just dump, just do pickle.dump and write your model name and the file which you have created here. Once this is run, once this is successfully executed, you can see a pickle file is generated here in your system. Before moving forward, please subscribe to our channel if you are enjoying this video. Now we have to create a few files for our web application. Before that, we just have to install some libraries. So I've written here the name of all the libraries which we need to install. Yeah, so we need to install Flask, OS, JSONify and requests. For doing that, just activate the environment as usual. And get into the path where our folder is saved. Once this is done, just type pip install Flask. Here it shows requirement already satisfied because I have already installed it. And similarly, we just have to install all the other libraries. Moving forward, now we have in our folder, currently we have few files which we have to create. The first one is requirement.txt. For that, just go to your command prompt. After all the libraries have been installed, just type pip freeze requirements.txt. Just type this, and once this is executed, here you can see that a file has been created. I have already created the file, so I am deleting this one. Next, we have to create a runtime.txt. that can be done directly by right clicking and opening a file. We just have to write the Python version we are using here. Next is the proc file. I'll just open and show what do I have inside. Just copy this and put it in your folder. The file name should be the same. Next, as we are working in Flask, we have to follow a certain structure. So first we have to create app.py. Then for our index, our web application, the HTML and CSS code, we have to first create a folder known as templates. The S should also be there, or else it won't work. After opening it, just create index.html. The name should be the same. Next, if we want to put any pictures or something in our web page, we have to create a folder named static. Just open it and we can put any pictures we want. Once this is done, now we have to upload the whole thing into our GitHub repository. So just open your GitHub, go to new, write any repository name and create the repository. Once this is done, go to your folder, give a right click and open git bash here. Once this is open, just copy everything which is mentioned here. If you have already created a repository, or if you want to check that if your GitHub repository is completely updated or not, just go to git bash, check for the status, type git status. Here I can see that runtime.txt, the modified version, is not yet uploaded. So what I'll do is I'll just write git add git commit with a message, say bugs fixed, and I'll write git push. Once this is done, I can again check the status, and now it will show that your GitHub repository is clean. Once this is done, now we will start working on Spider. For that, just right click and open another Anaconda prompt. Just type the regular activate incomplete to activate the environment and go into the folder location. Once this is done, just type spider. Let's start with the index.html column. Here we have written the complete HTML and CSS code. We have used the form element to create the form. The method used is post method. Here first we are displaying the results. So the prediction text will be displayed here. Here we have used table so that we have proper rows and columns for our form. So here what we have done is for the numerical columns we have just given a normal input field, and for the categorical columns we have given the drop down. So starting with the age column, age is a numerical column, so it will have a normal input field. Here the name variable is very important, as this variable age will be used in app.py, which I'll be showing further. Moving on, the second column is the work class column. Here we have used a drop down, so we have given all the values here. And if you remember, in the code we had converted all the categorical variables into the numerical values, so those values will be given here. The values must be right for the correct prediction. Similarly, for all the other fields, we have given drop down as well as the normal input field wherever necessary. Once this is done, here we start the CSS part. I won't be explaining the CSS part, just scrolling a little bit for you to get an idea about it. You can pause and check if you want. Next we go to the app.py. Here first I've imported all the libraries. Here I've created the instance of the web application. We have created a variable known as model, and we have loaded our pickle file here, incomeprediction.pkl. Next we create a function and return our index.html here. Now we create a function predict. In this function, all the inputs which we have taken from the index.html have to be given. So we'll write request.form and the variable name. The variable name should be the same as we have written here in the name section. So I've written all the inputs here. After that, the final prediction, we have to write model.predict and give all the variables which we have mentioned above. And here the condition, if output equals to 0. If the output of this prediction is 0, then we will return income is less than or equal to 50,000. Else we will return that the income is greater than 50,000. To run the application, just go to your Anaconda prompt and type python app.py. Just copy this URL and paste here. Here you can see that the application is completely running, and I'll just put some input values. After submitting, I get the result. So the web application is completely running fine. But this application is still running on your local host. To deploy the application, now let's open Heroku. Go to next, create new app, write your app name, for example, income pred by WDB, create application, click on the GitHub option, give the name which you have given as your repository name on GitHub. I've written income prediction. Just connect with that. And deploy a branch. Now we can see that the app has been launched, and just copy this URL and here our app has been deployed. I'll just put some random values to check if the app is completely working or not. And yes, it gave results. That's all for the day. Thanks a lot for watching this video and have a nice day. If you liked the video, please like, share and comment below.